everyone. My name is Rue. I'm going to talk today about mobile games and about testing them and the challenges that we have there. And I'm going to tell you the story of one of the projects that I've worked on, trying to help mobile game companies write automated scripts for games. I'll tell you a little bit about myself. I've been a tester since 2002. I've mostly done mobile app device testing, test automation for mobile, and I'm in general very much into mobile devices and mobile apps. I work, and I'm one of the owners at Altom. We're a company doing software testing services. We also do online training. We have the BBSD online classes that I am one of the instructors for. We're based in Cluj in Romania, but we also have an office in Helsinki, and that's where I'm located. I've been there for about 6 years now. And lately I've worked on a project with a Finnish company called Bitbar. I'm going to tell you a little bit about their main service, which is Testdroid Cloud. They offer access to real devices in the cloud through the internet. You can get access to them either like actual remote interactive access, or you can run automated scripts using the most common test frameworks online. They have about 500 unique devices. They have both iOS and Android devices. And you know, with Finland used to be the land of Nokia, now it's the land of mobile games because of companies like Rovio and Supercell. And some of their clients obviously are mobile game companies that are trying to kind of use their devices to run automated scripts to get fast feedback on new builds and so on. And there are a lot of challenges when it comes to that, and I want to talk a little bit about the context of mobile games, about the challenges in testing them in general. This is already a famous image. If you've worked in mobile, you know about this. This is from OpenSignal. It represents the Android device fragmentation from 2015. They release these every year. Every little square over there represents a distinct Android device that's been seen in 2015. So obviously this is a problem for testing. If you think about trying to cover all these devices and trying to figure out a strategy to deal with them, it's a big challenge. And I want to kind of define what fragmentation is, because it's not just about the combination of hardware and software and the number of combinations that you might have, but it's more about the inconsistency that this combination might cause in the end user experience. So someone with one device, one hardware, one Android version might have a very different experience from someone with a different Android device with a different Android version. And I think this inconsistency in user experience is even worse for mobile games compared to mobile apps, and I'm going to try to kind of make the case for that. Also because, at least in my experience, if I think about how to deal with fragmentation, I often think about what I do for web testing. This is the first type of context where I've had this problem. Many different browsers, many different operating systems. You're trying to kind of find a way to test throughout the combinations that you might have. And then for mobile apps, the same problem, generic problem of dealing with many devices, many different operating systems. So I think the most typical approaches that I've encountered are you either use some kind of automated scripts to cover as much of the repetitive checks that you have, and I think it's usually both, you try to focus on the most common combinations. And I'll try to talk a little bit about these two approaches in the context of mobile games, and try to talk about the challenges of both. I'll start with the most common combinations part. Biggest problem with games when you talk about the most common combinations is most common where. And this is again from OpenSignal. It's a map that shows the most common brand in different parts of the world. The map looks very similar in Europe and North America, but if you're a game company, mobile game company, Asia is going to be a huge market, and that looks very different. And similarly, of course, if you're from Asia, North America and Europe are going to be a big market. So you're going to care about, not just one market, which is more or less the case with a lot of mobile apps. It's a very targeted, usually, it's a targeted application. You have a market somewhere, it might be even just one location. For games, usually, you want to reach internationally, so you're going to have to deal with an international market in that sense. And of course, this is just by brand, so there might be other criteria as well. I think, yeah?
Sorry for interruption. How come iPhone is not listed?
This is just for Android. I think for iPhone, the situation is in general a lot easier, even though it's getting more complicated. This is more, in the case of Android, we have a much bigger problem with fragmentation in general, because there's many different brands, many different versions of Android. On iOS, the situation is generally more straightforward. Yeah. Yeah, sorry, I forgot to mention. This is the data was just for Android. Sorry. Yes. Yeah. So if you would try to choose the most common devices, I think, not just by brand, but in general, try to come up with the most common devices in different places. Even if you wanted to cover the whole map, then you might end up with a list that's so long that you again have to find the most common out of the most common. So you end up with a situation that doesn't really help you with what you're trying to achieve. And the other thing is, that the brand is just one thing. Then you'd have resolutions, and this is where with iOS it's already getting a bit complicated there as well. They already have different resolutions. For Android, there's a problem with versions of Android operating system. iOS is a lot better about keeping their users, or Apple in general are better about keeping their users on the latest version, but that's not the same for Android. And of course, these problems are the same for mobile apps. I think what's different from games in general is the fact that there are so many other factors that are important, because for games, you have graphics that can make or break the game, and the same with performance. If the game doesn't look good, if it feels laggy, if it doesn't work as you'd expected, it's not going to be a popular game. So you're going to have to care about things like memory or CPU or a lot of details, hardware details that might not be so important for a mobile app. It's not going to be so resource intensive. So these are, some of the things that are just specifically challenging for mobile games. And the other thing is you're going to care about low-end and mid-range devices. You're going to care about that because a lot of the customer base, your customer base, are going to be kids that are probably going to have their father's iPhone 5 rather than the latest iPhone 5S and so on. So they're not going to have the high-end devices, which is a lot of the times the case with, a lot of mobile apps are targeted at, whatever, IT professionals or business people, or that will have the high-end devices and you don't need to worry about low resources or, not the best CPU and so on. But this is very important for games, and it's specifically important because the games market is extremely competitive. And I have here quite a few. I spent a lot of time researching this, and I got really, really interested in the numbers, so it was hard for me to kind of stick with a few. The photo doesn't scale very well on the screen, but it's just a snapshot of my own Android Google Play accounts that shows the mobile apps that are the biggest, that make the biggest revenue. Most of them are games. And games will be the biggest money makers in terms of mobile apps. And last year, in 2015, only the top 10 games made over $6 billion. That's a lot of money. And also, I just watched a presentation by the Supercell CEO, Ilkka Paananen, where he's talking about this research that was done that says, first of all, that the top 10 games companies make 50% of that revenue. So, that means a lot of competition to get in the top 10, to make it there. And on the other hand, the same study showed that there are 10,000 games submitted every month. And this is where I got a bit geeky, and it was like, oh, that means actually 14 new games every hour submitted to the app stores. That makes it really, really competitive. You're going to care about low-end devices and as much as you can cover out of that Android device fragmentation to make it in such a competitive market. So, looking at the approach of choosing those most common combinations, it's going to be hard to do that for mobile games, and on the other hand, we no longer have to. Because if we think about the services like Testdroid Cloud that we were working with, you can have access to hundreds of devices, and the only, you no longer need to choose your most common ones or try to work through that problem. Instead, you can just use all of the ones that you already have available. You don't need to actually purchase yourself. It's a big investment if you think about, I don't know how many of you work in mobile testing, but if you're trying to kind of build your own mobile lab, it gets very expensive very soon. and new devices, go out of fashion very soon. So you always need to kind of invest in the latest ones, and that becomes a really huge investment. So kind of leveraging something that's already out there and you can use, it's a very important point. And plus it helps with not having to just go with the most common ones. Of course, to be able to leverage those hundreds of devices, you need some kind of automation. You need some way of, you have the same problem. You have 400 devices, but how do you test on them? So you need to kind of have a strategy to only focus or like to get feedback very fast, and that means usually automated scripts. Now, you probably guessed this, but there's also some challenges with that in mobile games. We're used to having a lot of frameworks that work for both iOS, for Android, that give us access to the native APIs, and we have access to the web elements. That's not the case for most mobile games because they're developed in game engines like Unity or Unreal Engine. And that means that the whole game logic, the graphics and everything are developed in Unity, let's say, and then they are exported for different platforms. So you get a binary application, an IPA or an APK for Android or IPA for iOS. You install it, and when you try to look at to kind of like explore your mobile elements through some framework, all you have is one big canvas, one big image. There's no buttons, no menus, no nothing. You don't have any of the native elements that you'd normally have access to. And of course, some of the frameworks do have their own support for testing and different test frameworks, like Unity apparently has a pretty good test framework. But it's very much focused on unit testing, and it requires a lot of instrumentation on the actual app that you test with, that it's no longer the build that you're actually going to send to the app stores. It's going to be a heavily modified debug or test build or whatever you call it. And it's very, a lot of the game companies are looking for a way to kind of UI, to build some UI-driven tests. Very simple ones that install the real binary application that they're going to send to the stores and check how the game looks on different devices. And that's very unlikely to do with tools that are from the game engines like Unity. And then when I kind of started working with Bitbar and Testdroid Cloud on their mobile game companies projects, what these companies were trying to do was basically click at coordinates, because that's what they were left with. And that, of course, is not feasible, not reliable. If you move from one device to another one with a different resolution, all your coordinates are not going to be correct anymore. And this is where the idea came to use an image recognition algorithm, where you do have one big canvas, that's one image. If you could find the elements that you're looking for in the game on different resolutions, then you would know the exact coordinates. So the problem wouldn't be there anymore. You'd know the exact coordinates on every device model, and you could literally just do click out coordinates because they would be very exact or precise. I don't remember your distinction there in your talk. So I started working with Bitbar on this project where we started with one company to build a test framework that would allow for customers to build scripts that are easy to use and that define their mobile elements or game elements using reference images, and on top of that use image recognition to find those objects on actual screenshots from the device. And once that was built, we were going to try to make it available to be run in the cloud on Bitbar's hundreds of devices simultaneously. Now when it comes to, we decided on OpenCV, which is the most common image processing library out there. It's open source, it's very, very used. It's very, very powerful as well. They have a lot of algorithms available that you can just use for image processing and image recognition. Our main idea was to choose an algorithm that doesn't, do an exact match or pixel perfect match of what we were looking for in a scene, because what we were looking for is something like this. This is the feature matching algorithm, or one of them from OpenCV. It's called Akaze, the one that we chose. I'm not going to go into details about it, but the point is that it allows us to kind of find that cookie box in a garbage bin, even though it's on a different different angle, rotated, and not even, it's also partially hidden by that rice box and so on. So we're kind of looking for matches for each of the pixels, and then based on the best ones that we find, we kind of guess that, okay, the image bus speed in this position, rotated this way, and so on. And the best part about it is that this is resolution agnostic, and it will find items even if they're stretched or rotated or a different angle, because in games we're often talking about the 3D space. So this is an example from The Sims. Again, this, like, I'm going to mention this for the next example that I show. This is not one of our the games that we work with. It's just one of the examples that I chose from the Google Play Store. I took the APK, and because all I'm doing is image recognition and screenshots from the device, I don't need absolutely no instrumentation of the app. So you can just take the APK from the Google Play and kind of run with it and write your test. At least for Android. Of course, for iOS the situation is different because their platform is different and won't allow that. But in this case, what we want to do, this is from the tutorial in The Sims. You have the house there, the main house that you get when you start your game. And this is the exact image that, the exact screenshot from which I took the reference image, let's say. We can find this, well, of course the green frame shows where the algorithm finds the image. It's going to find it even if it's a little bit rotated or a little bit more, or even a lot zoomed in, different angle. The character is no longer in the house. And still, we find the house because there's enough matches for the algorithm to know, okay, the house is there. And this is good enough because for most of the cases in what the framework that we were trying to build, we don't want to know exactly if the house looks like in the reference image. We just want to know if it's there. We just want some way of controlling the flow of the game. And doing that allows you to kind of define your mobile elements. Instead of using the native buttons and menus, you can define your own using reference images. And I have some example here. This is again from another game. It's called Hill Climb Racing. It's another Finnish company, not one of our customers, but just an example that I took. This is the main game screen that you see when you install the game and run it. So assuming that in this case, we just want to see that the game is loaded, and to me that means the car is there. And then kind of walk through the menu that we have, the more and get coins and next. This is how the actual code would look like for doing that, just going to the more button and going back. We wrote the code, we wrote the framework in Java just because the first client that we worked with was using Java and was interested in having the framework in Java. But in theory, OpenCV supports many languages, so it could be Python if anyone wanted, but it's just Java for now. We're using we used a JUnit for us, to write the tests. This is one of the JUnit tests that we have. We kind of built this framework all these methods that are very easy to use, like find image on screen car, and to define our car element, we just use, of course, this type of an image. Everywhere where you want to see the car later on, you can just reference to this one. This one's taken from one device, but it's going to be found even if it's an iOS or an Android device, different resolution, and so on. Then we have things like tap image on screen, which is going to first assert that the image is there. So it's going to do the find image on screen first, then actually tap in the middle of that found image. So that gives us the exact coordinates of something. Like we said, tapping at coordinates is great if you can know exactly what the right coordinates are. Of course, then we tap one back and then we find the car again. This is how the kind of the results would look like. When running the test, you get this screenshots that show where the image that every time you were looking for an image or tapping on one, we'd show it in the scene or in the screenshot. For the car, it's a bit difficult to see, but it's also there, the green frame. Now, this is all about the image recognition part, or the code, or the methods, and the things we build for easy access to different, or to define your elements and find them on the screen. In terms of interacting with different devices, we used Appium. We chose Appium mostly because it's open source. It has quite an active community. They're pretty good at keeping up with the latest changes. And it supports both iOS and Android. This was, of course, important in our case because we wanted something that would allow us to take screenshots, and tap at coordinates. These were basically the main functionality that we were looking for from the test framework, and interacting with the application or installing it, not installing it, and so on. Appium offered that nicely. The way I describe Appium in general, it's like the mobile implementation of Selenium WebDriver. It exposes the native elements from each platform using the UI automation or UI automator APIs through a Node.js server, and from there they're available through HTTP like any other Selenium WebDriver elements that you'd look for on a web page. So we chose Appium, and again, so far everything happens locally on the developer machine, let's say, or on the person developing the scripts. Locally, we have the OpenCV, the algorithm we use, the Java code, and Appium running locally. And this was, the way we developed the first scripts, and then we wanted to get to the point where we actually run them in the Testdroid Cloud. This is again the main point: kind of leverage the access you have to hundreds of devices, some one way or another. And I'm going to quickly walk you through how that running a test in Testdroid Cloud would look like with this algorithm. You'd upload your APK, you'd upload also your test files, which in this case means an archive with the Maven project with all the JUnit tests. And then you kind of choose the device group that you want to run with. You could create your own device groups. You could have hundreds of Android devices if you want to run with all of those. You can filter them, of course, by API level, for example, for Android, or just run on iOS, or just run on Android, and so on. And then you'd start the test. And in the background, what would happen is we'd start a container with OpenCV and Appium and everything installed for each of the devices in the group that you choose, and kind of run the tests just like you would locally, but in a separate container in the cloud, and then kind of present the results back. So in this case, it's for the same hill climb racing example that we used with the car. The tests just install the app, go through the menu, and then kind of play the first level of the game. This takes, on average, you can see the test execution, it's like around 5 minutes, I guess. You can have results in 5 minutes from hundreds of devices. Very simple results, but you kind of make use of all the available devices that you have access to now. This is how the an individual report would look like in the cloud. It's very small, it's not that important, so it just shows there are 3 tests that we ran. These are all the screenshots that we took during the test run execution, and then the performance data from the device. In this case, we see CPU and memory usage, and then now I think Bitbar is also working with Game Bench, so you could get frames per second and other whatever you'd be interested for a game in terms of performance. Of course, this is very useful. You get all of the logs and everything like that on top of this for each individual run. But what I find very, very interesting is that you can have this view in the cloud where you can compare screenshots on different devices. So you get this view where you'd see at a certain point in the test run, and this is the same screenshot we saw with the More button, it would show you how that screenshot looks on all the devices that you ran with. It's extremely useful because you can quickly, as a person, as a human, and not an automation script, it's very easy for you to look at, in comparison, all of the screenshots and say, oh, okay, there might be a problem on this one here. In this case, there's some white space, let's say, and we want to go in and see, oh, okay, what's wrong with that? You could click on it, go and see the individual results, and then if something's really strange, you can even connect to the device remotely, install the game, and interactively play it to see what's happening, if there's something, some strange behavior that you cannot figure out from the screenshots that you have. So this was, in short, the whole framework that we built and how it's being used now in the Testdroid Cloud. I have some conclusions on what we figured out after running and using this framework with quite a few clients. Because we've had a few projects and got to use, well, at least from Altom's point of view, we worked with a lot of companies to help them first set up their scripts. Sometimes they would pick it up from there and develop their own. Sometimes we help them actually write all the scripts they want and then maintain them later on. We got to a point where the framework itself was extremely reliable. We got it to work really fast. Even the image processing we got it to a point where it was really, really like fast, really. And we realized that it was, for most of the customers, it was extremely useful right from the start. We'd start with very simple scenarios and run them on, all of the devices available, and we'd find immediately a lot of problems, and the most common ones were crashes of the game, out-of-memory problems on low-end devices, and problems with the graphics, missing graphics altogether, and graphics that are not displayed correctly. These we'd found, like I said, with very simple scenarios, and we'd start with that and kind of work through those problems. The customers would fix those issues first, and kind of we've moved from there to more complicated scenarios. But we've learned to stick to the straightforward ones, in the sense that we'd go only installing the game, checking that it's loaded, check how long it takes to load the game. This is very important because a lot of the times people won't even wait to see the game if it takes too long. And afterwards, once that's okay, you kind of navigate the menu and then move on to kind of playing the first level, finishing the tutorial, that kind of stuff with this type of script. And the idea is, again, not to check everything automatically, but to have enough confidence to know that you can walk through the game confidently, screen by screen, and take screenshots, and allow someone else then to come back after the 5 minutes it took to run the test on all of the devices, and kind of look through the screenshots and check for problems visually and very fast with a human involved, because that's a lot faster than anything we do automatically. So the biggest, I think the biggest advantage from using this is knowing that you can safely navigate the game and check for certain basic things and make sure that the app doesn't crash and so on. So I think these were the main things that we found. We're still working with some companies. Just last week I actually read an article of a different game company that was using the code and kind of running their own scripts and then running them in the cloud. People seem to like it, they find it very useful, and I feel like we've done something that was quite rewarding, in the sense that we see how it helps mobile game companies to get fast feedback from their new builds or new releases. I don't know if I have time for questions, but I'm happy to take some. So.